All right, hey, this is week one for Intro to Computer Programming for Business Majors, part two of the intro lecture here. Again, this is a very introductory look into computers and software right now. So, programming languages. A program is a set of instructions on a computer that follows in order to perform a task. Programming language is a special language used to write computer programs. A computer program is a set of instructions that enable the computer to solve a problem or perform a task. Collectively, these instructions are known as an algorithm. An algorithm, which, you've probably all heard the evil algorithms for AI and stuff everybody rants about on the news because they don't know what algorithms are. But so an algorithm is just simply a set of well-defined steps to complete a task. The steps in an algorithm are performed sequentially, meaning, and again, so you think about the orders you'd take to make the peanut butter sandwich. It's the algorithm. Computer needs an algorithm to be written in machine language. Machine language is the binary numbers. It's the base 2 we were looking at before, the ones and zeros, because we're digital. Remember, we're digital, so we can only read 1 and 0. So the computer needs that in ones and zeros. That's all it can read. It's machine language. We don't want to write in machine language, trust me. It's much better to use a programming language. So the binary numbers are encoded as a machine language. Each CPU has its own version of a machine language. These are different CPUs. An example of machine learning instruction would look something like that. Machine language instruction, something like that. The distant past, programmers actually wrote in machine language. Programmers developed a high-level programming language to make it easier. The first of these was assemblers. Assembler made things easier, but was also processor dependent, which meant it wouldn't run across multiple processors. High-level programming languages that were not processor dependent followed. And some of these programming languages are below here. We have Java, Basic, COBOL, Pascal, PHP, C#, C++, C, Visual Basic, Python, Ruby, JavaScript. There's so many more that you can keep going on to, but that's the idea. The great thing about programming languages, they look, in general, they look closer to real language than they just ones and zeros. So we use words, keywords, operations, punctuation, program-defined identities, those types of things. They're strict syntactic rules, but it's much easier than trying to write in binary. Here is an example of a programming language in Java. Now, I'd like to point out a few things. Number one, your headache in this class is probably going to reside around these little curly Q brackets. You want to make sure that you are inside the correct set of brackets because these brackets contain these two lines only, whereas these brackets contain all this. And you also want to think about your semicolons. Semicolons need to go at the end of most lines you write. And what this program does literally does nothing more than print out hello world. And we'll get into this with class, and you need to have, and this is a Java thing, it's related specifically to, you need to have a public class and the public static void main. And we'll get more into why you need these classes and stuff later. But this is just an idea of what the syntax kind of looks like. These are all keywords. System.out.println prints this message out. These are pre-designed words that every one of these means something to the system. So it translates these words into machine language so the computer can use them. Some of the keywords used in that sample program were public, class, static, and void. Keywords are lowercase. Java is a case-sensitive language. Keywords cannot be used as a programmer identifier, programmer-defined identifier, which is another word for variable. So assigning the word message here as hello world, this is a variable. Or what word do they call it? Programmer-defined identifier. Right. It's a lot of words for variable. All right, semicolons are used at the end of Java statements. However, not all lines of a Java program end a statement. Part of learning Java is to learn where to properly use the punctuation. There are differences between lines and statements when discussing source code. This is one right here, is one Java statement we're using 2 lines. Do you see a difference? The statement is a complete Java instruction that causes the computer to perform an action. It'll do the exact same thing. It doesn't matter how many lines you're on. What matters is once I put the semicolon, that tells you this line is done, complete, whatever it needs to be done in this line. Data in a Java program is stored in memory. Variable names represent a location in memory. Variables in Java are sometimes called fields. Variables are created by the programmer who assigns it a programmer-defined identifier. Example, I'm assigning the word hours, that would be my variable, the value 40. And I'm telling you it is an integer, which if you guys don't know that, integers are whole numbers. They have no decimal point. If you want a decimal, you need like a double or a float or something like that. Variables are simply a name given to represent a place in memory. So you know when I've given that name, it knows that's the address I've placed it in, okay? Assume there's a variable declaration that's been made length 72. The variable length is a symbolic name for the memory location of 03 here, and it stores it right there. So when I go to pull up length, it knows to look in this spot for what the value is. The Java virtual machine actually decides where the value will be placed. Now, the Java virtual machine is part of the magic that makes Java what it is, that it doesn't care if I'm running on a Windows or a MacBook or Linux or on an Android phone, because everything runs off the Java virtual machine, which is its own little device. It sits on top of your software, and that's what it runs on. And not really something you'll ever have to interact with yourself. It's more unless you decide to become a computer engineer. Compilers in the Java virtual machine. A programmer writes a Java program, statements for program. These statements are called the source code. That's the program you wrote. You use a text editor to edit and save the code as a source file. You save it as a .java file extension, okay? A compiler is a program that translates the source code into an executable code, so something the computer can make sense of. So a compiler is run using source code files and input. The syntax errors that may be in the program will be discovered during compilation. Syntax errors are mistakes we make as a programmer. Like I said, if you miss one of your brackets or something like that, and you break the rules. The compiler creates another file that holds the translated instructions. Most compilers translate source code into executable files not containing machine code. Java compiler translates Java source file into a file that contains bytecode instructions. Bytecode instructions are the machine language of the Java virtual machine and cannot be directly executed by the CPU. But that's the beauty of it, is that you don't need the CPU. It doesn't matter what kind of CPU is in your computer. It's because everything resides on the Java virtual machine, which is what makes this usable across any platform. Bytecode files and with .class. A JVM program that emulates a program that emulates a microprocessor, the JVM, the Java virtual machine. It executes the instructions as they're read. It's called an interpreter, and Java is often referred to as an interpreted language. So you write your code here in a text editor, save it as a Java file. It's read by the compiler, produces a class file interpreted by the Java virtual machine, and you get the results of program execution. That which brings portability. Portability means a program can be written on one type of computer and then run on a wide variety of computers with little or no modification. Java bytecode runs on the JVM and not on a particular CPU. Therefore, compiled Java programs are highly portable. Java virtual machines exist on many platforms. BSD is another. Maybe if you go to like scientific research, you'll find some people still rocking BSD, but it's, with most programming languages, portability is achieved by compiling a program for each CPU to run on. Java provides the JVM for each platform, so the programmers do not need to recompile for different platforms. So take the code, the class file, the bytecode, and you could run it on any machine because it's a Java virtual machine sitting on any device. Software you use to write Java programs is called the Java Development Kit, or JDK. There are different editions of JDK. You got the standard edition, which we'll use. You have the EE, it's the enterprise edition. That's used for big companies, that kind of stuff. The ME is micro edition. That you'll find, when you're looking for your phones or, a lot of this Internet of Things like cameras and stuff out there that are running small Linux operations. You can get Java for free. Just go to Oracle or just Google JDK download. Java compiler is a command line utility. The command to compile a program is jvac filename.java. Jvac is the Java compiler, and the .java extension must be used. Example, to compile Java source code payroll, you would use the following command: jvac payroll. All right, the programming process. What are we at here? We're going to stop. We'll go ahead and make a third video.